Ever wish you could show your boss how hard you're working or your professors how hard you're thinking? Besides the amount of time we invest or the workload we complete, currently we have no real means of measuring how much effort we put into a task. But a computer scientist and a biomedical engineer at Tufts University in Massachusetts teamed up to create a non-invasive tool for measuring brain activity and calculating productivity. They say this can open up an entirely new world with new methods for communicating with our electronic devices. It also gives us the power to decide how much brain power to invest in each task while increasing our productivity by bypassing distractions.
Think of human and a computer as powerful information processors connected to each other by this miserable low bandwidth connection of the mouse, the keyboard, the display.
And when they go away, we try to take them away.
My specialty is human-computer interaction, so we study how people communicate with computers. I visited Sergio Fantini's lab, and I saw that he had an optical device for measuring activity in the brain. This is great. You don't need to lie in an fMRI, you don't need a complicated setup, and you can measure brain activity in real time. We're looking for ways to improve the communication between the person and the computer, and we thought using information from their brain would be one way to get more bandwidth between the person and the computer.
These are the optical sensors. I'm a professor in the biomedical engineering department, and I have been working for a number of years on biomedical optics, which are ways of using light to study biological tissues, and in particular diffuse optical methods, which is just based on red and near-infrared light to study tissues at an organ scale. My lab has been traditionally focused on functional studies of the brain, and when Professor Jacob approached me because he learned about the technology and suggested a different kind of application, it was a fantastic opportunity for the field of near-infrared spectroscopy.
We're using a technology called FNIRS, Functional Near-Infrared Spectroscopy, to measure changes in the state of your brain. With the equipment we're using, you place a pad on your forehead. The pad contains fiber optic cables which lead to a box that has a light source and a photosensor. It takes a very small amount of time to set it up. We shine a light, a near-infrared light, into your head, and you thought your skull was opaque, but actually it's transparent to certain frequencies of near-infrared light. We shine light in and we see light reflected back.
It was a fantastic collaboration that really started on identifying a new application for a technique that really has among its strengths the fact that it can be applied in an everyday environment.
FNIRS is measuring oxygenated and deoxygenated hemoglobin, which is the amount of oxygen in your blood as it flows to your brain, which tells us how hard a particular part of your brain is working or not working. So we can measure which parts of your brain are needing more oxygen from time to time. Very similar to what an fMRI, functional magnetic resonance imaging system, measures, but much less trouble. fMRI, you have to lie in a special tube, you have to be motionless, you can't have metal around. With FNIRS, you can sit in a normal chair in a normal office, and it's much more practical for human-computer interaction. So as we measure your workload, we're measuring roughly how hard you're working. If they don't have enough work to do, they're going to get bored. If they have too much work to do, they'll get overloaded and not do a good job. So we'd like to adjust their workload.
It's not the user who says, now I'm too tired, I need to have the interface change. The idea is to have something that is invisible to the user and is able to adapt the interface in a way that is transparent.
It would be much too much trouble to ask the person to constantly adjust a setting. So are you busy now? Are you not busy now? That'd be very annoying and distracting. But if we can measure it automatically with no effort on their part, we could just adjust smoothly and unobtrusively.
So this is the UAV controller task. It's very similar to an air traffic control task. The participants are tasked with clicking on these vehicles. They then create a series of waypoints, and they create a path between the vehicle, these waypoints, and their destination. In the meantime, they're trying to juggle handling a whole bunch of UAVs at the same time and avoid the obstacles. The obstacles are moving, so they constantly have to be sort of attentive to these vehicles all at the same time. So we try to keep the user in this state of flow where they have the optimal challenge for their skill set.
We measure how hard people work because that's the easiest and most reliable measurement we've been able to get with this equipment. We'd like to measure emotion, but we've started with short-term memory workload because that's the thing we can get the most reliable signal. We use a heavy dose of machine learning to try to interpret the signal and figure out exactly how hard the person is working. So it's noisy and imperfect. On the other hand, it's absolutely better than what the computer knows about your mental state otherwise, which is nothing. We also started a new project recently with Google using Google Glass, where we're trying to use brain measurements as an input for Google Glass. Google Glass gives you a wonderful set of information. It can provide all kinds of useful information in the screen all the time. What it doesn't have is a convenient way to tell it, now I'd like information, now I'd like you to shut up and leave me alone. It has a touchpad, but that's a little bit awkward. So we thought we could use brain measurement as an input to this.
Okay, Glass. Start Glass Roots.
So we can find out what state your brain is in and decide when the Google Glass should give you information and when it should leave you alone. And we're putting together an experiment where we're going to do just that. You're giving the user a complicated task and see if this automatic turning on and off is helpful. My goal is to improve communication between people and the equipment they use so that it's more natural, more convenient, less distracting from their lives.
That's it for this week. Join the conversation with us on social media. We are CCTV America on Twitter, Facebook, and YouTube. All of tonight's interviews can be found online on CCTV America's YouTube page. And let us know what you'd like us to take full frame next. Email us at fullframe@cctv-america.com. Until then, I'm Mike Walter in Los Angeles. We'll see you next time.